Good morning, fifth graders. Today we are going to do lesson 2.3 in stretching and shrinking. We're going to be talking about mouths and noses for the mugwumps. We will start by going over the work from yesterday with the hats. So let's take a look. This is what your hats should look like. Question A was asking you to make predictions. So I didn't put that on this screen because everybody's predictions would be different. So the first one was Mug's hat. Then you had a rule of +2 for X and +3 for Y. And what happened to the hat? It stayed the same size. There was nothing being multiplied by the X and the Y, so the hat stayed the same size. Adding to the X and the Y moves the hat up and over. So X would move it over 2 and the Y moved it up 3. In hat 2, you moved it to the left 1 and up 4. Again, it's the same size. Rule 3 or hat 3 had a scale factor or a 3 times the Y and an adding in the X. So this hat got taller. Hat 4 got smaller. The factor was the same for the X and the Y, so the hat is similar. And hat 5 had a 2X and a 3Y, so the hat got both longer and taller, but because they didn't use the same number for both X and Y, it is not similar. So in question C, it says the angles and the side measures of hat 1 and 2 are exactly the same as Mug's. The width of hat 3 is the same, but the height is bigger. So the bottom angles would change. Both the width and the height of hat 4 are half as long, but the angles stay the same. The width of hat 5 is double and the height is 3 times, so all the angles will be a little bit different in that one as well. For C2, it says hats 1, 2, and 4 are similar because they have the same shape and corresponding angles, and their sides have been multiplied by the same factor. Hats 1 and 2, the factor is 1 because it didn't multiply by anything. In question D, it said X over 3, Y over 3. You may have said 1/3 X and 1/3 Y, or 0.3 repeating X and 0.3 repeating Y. D2 was 1.5 times X and 1.5 times Y, and D3 was X plus 1 and Y plus 5. In question E, you could have many different answers here. They chose 3X minus 2 and Y minus 2, or you could have chosen 4X and 3Y. Any two positive numbers for A and B, for X and Y, that are not equal to each other would work. Okay, sorry about that. I had to walk away for a second. So we finished talking about the work from yesterday. Today we are going to talk about 2.3 with mouths and noses. So how did you decide which the computer game characters were members of the Wump family? How did you decide which were imposters? So we decided by looking at if there was a scale factor, if there was something that was being done to the X and the Y, and if it was the same, if the angles were the same, then we knew that they were similar. So in general, how can you decide whether or not two shapes are similar? You have experimented with rubber band stretchers, copiers, and coordinate plots. Your experiment suggests that for two figures to be similar, there must be the following correspondence between the figures. The side lengths of one figure are multiplied by the same number to get the corresponding side lengths in the second figure, and the corresponding angles are the same size. And so that's kind of what we've noticed in the first two lessons here, is if you're multiplying the X and the Y by the same, or if you're multiplying the side lengths by the same amount and the angles stay the same, then they will be similar. So that's called scale factor. The scale factor is the number that the side lengths of one figure can be multiplied by to give the corresponding lengths of the other. The rectangles below are similar. The scale factor from the smaller to the larger is 3. Okay, 2 by 3 can become 6 by 9 because you multiply by 3. 2 times 3 is 6, and 3 times 3 is 9. Now, here's where we want to follow and read carefully. It says, what is the scale factor from the larger rectangle to the smaller rectangle? Explain how you found it. So how are we going from 6 to 2? And up here, we need to, your first thought might be that you're going to divide by 3, right? Up at the top, it says the side lengths of one figure can be multiplied by to give the corresponding. So what can we multiply by to go from 6 to 2? So dividing by 3 is going to be the same as multiplying by 1/3. Okay, 6 times 1/3 would be 2, and 9 times 1/3 would be 3. So how did we find it? We thought about the division. We knew the division, and then we changed it into a fraction. So in problem 2.3, you will have a collection of mouths, which are the rectangles, and noses, which are the triangles. Some are from the WUMP family, others are from imposters. And again, I've put this lab sheet right here in the 2.3 folder, so you could print it if you like. This is also in your book. You don't, just to make sure you're not writing in the book. So how are you going to figure out which are from the WUMP family and which are from imposters? Now, some of them you might look at them and be able to tell, but I'm pretty sure they're going to ask us to know exactly how we figured it out. So A is about the rectangles. Use the rectangles on the previous page or print out the worksheet. Which of the pairs are similar? Explain how you know. For each pair of similar rectangles, find the scale factor, that is the number that's being multiplied, and the perimeter and area of each rectangle. So each one that you find to be similar, each pair that you find to be similar, what is the scale factor, what are the perimeters, and what are the areas? Okay. 3 says, describe the relationship between the perimeters of 2 similar rectangles and the scale factor. So how is the scale factor and the perimeter of the 2 things related in general? You don't have to say for each one on this one. So if my scale factor is times 2, how will that change my perimeter? Then it says describe the relationship between the areas of 2 similar rectangles and the scale factor. So again, if my scale factor was times 2, how does that change my area? Then in B, you're looking at the triangles. Which pairs of triangles are similar? How do you know? For each pair of similar triangles, find the scale factor and the area. Notice they're not asking you to find the perimeter of the triangle. Do the same relationships between the scale factors of similar rectangles and their area apply for similar triangles. So when you're looking at the area of a triangle and its scale factor, is the same thing happening as it did in the rectangles? Then number 4 says, draw 3 right triangles such that exactly 2 of the right triangles are similar. Explain how each triangle is similar or not similar to the other 2. So they want 3 right triangles, 2 that are similar, and 1 that isn't. Question C says, after studying the mouths in the diagram, Marta and Zach agree that rectangles J and L are similar. Marta says the scale factor is 2. Zach says it is 0.5 or half. Is either of them correct? How would you describe the scale factor so there's no confusion? So it sounds to me like they might both be correct. Explain how to find a scale factor from a figure to a similar figure. How do you find the scale factor? What do you do? Does the scale factor change the angle sizes? We should know that by now. You have used rubber bands and coordinate graphs to make similar figures. How does the scale factor show up in these methods? So the rubber band, you might have to go back and look at your work. I believe it was about double. I can't remember if it was double or 1.5. Look back and see what yours was. And in the coordinate graphs, what did we do? We had a rule, and we applied the rule to the X and the Y. So I kind of give you the answer to that, C4. All right, and that is your classwork. Then we have homework 5, 6, 10, 13, and 19. And remember that this is the last lesson, or maybe you didn't know, this is the last lesson in Investigation 2. So tomorrow you will be doing the Investigation 2 review, which will also be posted on the Schoology folder. All right, thanks and have a wonderful day.